Hello, my name is Davis Binger, and let me talk to you about the area between two curves. This covers Chapter 6, Section 2, and I will be covering Problem 8 of the handout. The problem asks us to find the area of the region in the first quadrant bounded by the curves y equals the square root of x minus 1 and y equals 2. We can solve this problem one of two ways, either by integrating with respect to x or integrating with respect to y. Let's look at both solutions. Here's a quick schematic of the situation. We have the two curves bounding our region, y equals 2 and y equals the square root of x minus 1. But we also have two additional curves, which come from the fact that we have limited our region to the first quadrant. We have the curve x equals 0 and the curve y equals 0. Those are the four boundaries. Now, if we're going to integrate with respect to x, we need to find the interval of integration. That we can do by equating our equations. So we want to find the intersection of the lines y equals 2 and y equals the square root of x minus 1. We can equate them, square both sides, add 1 to both sides, and find out that these two lines intersect at a value of x equals 5. Thus our range of integration will be from 0 to 5. Our next step will be to find the top function and the bottom function. Okay, as you can see, the top function is given by the line y equals 2. The bottom function, however, is a little more complicated. The bottom of our region is given by the curve y equals 0 for a while, and then at 1 it starts being defined by the curve y equals x minus 1 to the 1/2. So our bottom function is defined piecewise, and on the interval from 0 to 1 it's defined by y equals 0, and on the interval from 1 to 5 it's defined by the equation y equals x minus 1 to the 1/2. So we will find the area by integrating the difference of the top and bottom functions on this interval. Since the bottom function is defined piecewise, we will have to decompose our integral into two separate integrals, one for each of the components of the piecewise defined function. So the first component was y equals 0 on the interval from 0 to 1. We have an integral from 0 to 1, which is the top function 2 minus the bottom function on that interval, which was 0. Then we have a second integral. The top function on the interval from 1 to 5 was defined by 2, and the bottom function was defined by the square root of x minus 1. These two integrals give us the area of the region. Now we just need to perform the integration. So the first integral, we integrate the 2, it becomes 2x. We can ignore the 0 just goes away. Now for the second one, the 2 again integrates to 0, and we have x minus 1 to the 1/2, which we can use the power rule on. Recall that the power rule, in the power rule you add 1 to the exponent and divide by the new exponent. So in this case, our exponent is 1/2 plus 1, or 3/2, and we divide by 3/2, which is the same thing as multiplying by 2/3. Now we apply the fundamental theorem of calculus, evaluate these functions at the rightmost endpoint and subtract the function evaluated at the leftmost endpoint, and we have the following algebraic expression: 2 times 1 minus 2 times 0 plus 2 times 5 minus 2 times 5 minus 1 to the 3/2 over 3 minus 2 times 1 minus 2 times 1 minus 1 to the 3/2 over 3. After performing a small calculation, we find that this is equal to 2 plus 10 minus 16/3 minus 2, which is equal to 14 over 3. Let's check and see if we get the same answer integrating with respect to y. If we're going to integrate with respect to y, we need to change our perspective. We're still looking for the top and bottom functions, but top and bottom mean different things relative to y. We're going to have to turn our heads and look at the top function relative to y. So relative to y, the top will be this curve y equals the square root of x minus 1. And the bottom will be simply the line x equals 0. And the y values for which the region is contained are 0 to 2. So our interval of integration is 0 to 2, our top function is y equals the square root of x minus 1, and our bottom function is x equals 0. Now we need to put the top function in terms of y. So we solve for x, and we find that the top function is defined by x equals y squared plus 1. Thus we will integrate over the interval 0 to 2 the top function y squared plus 1 minus the bottom function 0 with respect to y. This integrates to y cubed over 3 plus y, and we evaluate from 0 to 2, which is just 2 cubed over 3 plus 2, and after we simplify, this is 14 over 3, same as we got over x. Alright, so that wraps up the problem. Thank you for watching, and if you have any questions, you can either comment below or email me at binger@math.ohio-state.edu.